Today we are going to talk about acids and bases. And if you look on page 3, if you have your experiment booklet that we sent out to you, you'll see something that looks like this on page 3. And this is going to help us, this sort of diagram, it's going to help us learn about acids and bases. Acids and bases. And maybe you've heard of the pH scale. Maybe you've heard of an acid. Maybe you've heard of a base. And we're going to do some explorations today with acids and bases and the pH scale. And what's nice about acids, bases, and the pH scale is you get all these colors. So we're going to learn about all these colors and how we get them with acids and bases. So let's talk about that a little bit. So I think, let's see here. Phoebe, I think I want you to come up here. And let's have you pour a little bit of water in that cup. You're going to use that red jug right there. Yep, just pour about halfway. We'll get this out of your way. And I'm going to slide behind you here, excuse me. And why don't you pick one of these, we call these indicators. We call these indicators. Indicators are substances that change color depending on whether they're in an acid or a base. So why don't you pick one of these? Let's see, we've got, these are some fancy words. We got phenolphthalein, we've got universal indicator, we've got phenolphthalein, and we've got bromothymol blue. Boy, those are big words. But we're just going to focus on the colors. Which one do you think we want to use? We're going to use bromothymol blue. So take that orange. Yep, that's the one. Let's add a few drops to this. Oh, we're going to need a little more there. Here, let's try this dropper. Maybe. You got some. Good. Squirt it in there. What color do you see?
Clear to yellow.
Clear to yellow. Let's add a little more. We got a little more color in there. Clear to yellow.
I wonder what that indicates.
Yeah, that's beautiful. Well, what that tells us, what we're going to do is we're going to look at our chart for bromothymol blue. And as I look at this chart, I see some numbers, 1, 2, 3, 4, 5, 6, that all say yellow. And then at 7, it's green. And then 8 to 14, it's blue. Well, I'm seeing yellow. You're seeing yellow too, right? And that tells me that we say the pH of this water, of this pure water, is somewhere between 1 and 6. That's all we can tell with this particular indicator. And that means it's an acid. If you have something with a pH that's below 7, it's an acid. So all these colors here for the different materials, they'd be able to tell us whether we have an acid. And bromothymol blue tells us we have an acid if that substance is yellow. Now, if it's green, we have a neutral. That's neither acid nor base. And then if the pH is from 8 to 14, then we have a base. So let me write this on the board here, just so I get all this straight. We got a lot of stuff going on here. So let's see. Down here, these are our acids. Up here, these are our bases. And in between, we say pH 7. We call that neutral. Neutral. It's neither an acid nor a base. Let me stand out of the way so you can see that there a little bit. Acids, for this indicator, it's going to be yellow. If it's neutral, which it's not, I can tell it's not neutral because that doesn't look green. Does that look green to you, Dr. Baldwin?
That is not green.
I don't think so.
That is yellow.
And if it was 8 to 14, it would be a base, and we'd see a blue color with this particular indicator. So let's see if we can't make this. Let's see. We're going to let's add a base to this. Let's try. Why don't you grab some sodium hydroxide there, solution? Yeah, that's the one. She knows all this stuff because she's had our chemistry class here at Spring Arbor University. She knows what she's doing. So here we go. Let's just add 1 drop. Let's just add 1 drop of that and see what happens. Let's give it a swirl. Oh, here, I can mix it with this. Look at that.
Wow, that didn't take much at all.
Whoa.
Oh, wait a minute. Whoa, whoa.
That's green, isn't it? I think we made something. Oh, what's going on there? did you see it go from blue, basic, to green, that kind of yellow? That's a little yellow-green, but it kind of went through a progression, didn't it? That may sound confusing. See, what we did is we added a base. Go ahead and add another drop of that base. There we go. We'll add another drop. I'm going to swirl it around. It got blue. Yep. And as I continue to swirl, it might stay blue. I think, well, here, I'll help it along. I'll give you a hint as to what was going on when we saw that color change to get it go back down to yellow. I'm breathing into it. Why don't you go ahead and breathe into it there, Phoebe? There we go. My turn. Dr. Baldwin, you want to try? Oh, he's not in the room, right? He had to go do something else. We're all breathing in this to try to change the color from blue.
So that's a terrible breath.
There it goes. See, what happens when we exhale into this is that we breathe out something called carbon dioxide. And when carbon dioxide goes into water, it makes an acid. So we added a base. It made it go over here into the blue color. And then when we didn't breathe into it, there is some carbon dioxide in the atmosphere that dissolved into here, and that made us go back to acid. Then we added a little more base, and the carbon dioxide in the atmosphere wasn't strong enough to pull it back down to acid, so we had to breathe into it because we breathe out quite a bit of carbon dioxide. But it looks like we got a neutral now, don't we? Yeah, I think so. I think we got a neutral.
Yeah.
Let's add like 3 or 4 drops. Let's go ahead and make sure that this is a base. There you go. I think that'll work, yeah? Beautiful.
Yeah.
There it is. So what we've shown you here is we're showing you how scientists use acid-base indicators to see whether something's an acid, a neutral, or in this case, a base. And what's neat about indicators is there's a whole bunch of different types of them. There's not just bromothymol blue. We can use another one. Dr. Baldwin, which one do you want to use?
Well, I like the ones that are harder to say.
Okay.
So why don't we try phenolphthalein?
Phenolphthalein. All right.
Phenolphthalein.
Yeah, there's a lot of, oh my goodness.
It's hard to say.
Anytime water is exposed to the air like this, it's going to have some carbon dioxide in it. What did I say about carbon dioxide? Don't tell them. Do you remember what I said about carbon dioxide?
No, I don't remember anything that you said before.
Phoebe, do
now.
you remember?
By turning it to acid.
Oh, she's got it. It turns it to an acid.
Oh,
So if carbon dioxide is in the air
okay.
and some of it's got in here, then this is
Yeah.
probably an acid.
Should be.
And so if we
I
add the
think.
phenolphthalein to it, what do you think you're going to see?
Hmm.
Let's add a couple drops.
It should be yellow, just like last time.
Nothing's happening. Does that make sense? Sure, it makes sense because this is acidic because it's got some carbon dioxide dissolved in it.
And when it's acid, there's no color for this indicator, not for the first indicator. That was a different indicator.
That's right. So let's go ahead and add a little bit of base to this, yeah?
Okay, which
Phoebe, you mind throwing those out for me there? I'm gonna put those right there.
You want the 1 molar?
Yeah, let's try the
Strong
one more,
one?
the stronger one. Yep. So
Okay.
make sure we really whack this. There you go.
Whack it. All right.
Pop it
Okay.
in there.
Whacking. Oh, look at that. I can see some color.
Yeah. Let's stir it
Stir that
around.
around. Whoa!
There you go. We've made a base by adding the base, and our phenolphthalein has changed from colorless to blue, just like this is blue. You know what would be fun?
What would be fun, Dr. K?
I think it'd be fun to put a little bit of carbon dioxide in there, don't you?
Oh,
And see what happens.
absolutely. I don't think anything will happen because carbon dioxide, dry ice, is white.
Well, let's see.
Wait a minute. White is different from blue, so maybe it will change because the white dry ice is white, and with phenolphthalein, acid is white. There, I figured it out.
There you
I'm,
go,
I'm
right?
glad that I
Maybe
was
it'll
able
work.
to explain that.
Why don't you grab that dry ice down there?
Okay.
Oh, I said dry ice. Dry ice, got little pieces of dry ice here. Let's go ahead and take one and stick it like maybe on the counter here so they can see it.
Okay.
Just a couple. Yeah, there you go. Let's put it on the black. I think we'll be able to see
Oh,
just a little bit
yeah,
better if we
yeah,
stick
I
it on
think
the
you're
black.
right.
We'll move these
It's
out of your way.
amazing how you're good at figuring things out, Dr. K.
Yeah, well, we work together.
You've practiced a lot, haven't you?
Maybe. So yeah, these little, you notice I'm not touching it with my bare hand, okay? These pieces of dry ice, it looks like ice, but it's really dry ice. This is pretty much pure carbon dioxide. So if you get carbon dioxide gas cold enough, it makes a solid. And this stuff is as cold as a really bad day in Antarctica. So if I touch this with my bare hands, I can get frostbite.
Ouch.
It's like minus 110 degrees Fahrenheit. Really, really cold.
Makes me cold just thinking about it.
But remember, this is carbon dioxide, which when we put it into water, it makes an acid.
Oh,
So
that's
let's
right. Yeah,
let's try it. Let's put it into, oh, I forgot which was which.
I
They're both
remember.
blue.
They're both blue, but they're different shades of blue, aren't they, Dr.
They are.
Mm-hmm.
One of them's thymolphthalein, the other one's bromothymol blue.
These blues look the same,
They do. I might.
but these blues are slightly different.
They are a
This
little.
one's
Phoebe.
Thymolphthalein.
Oh, that one's thymolphthalein. Okay.
See,
Well, you
Phoebe
know what?
pays attention.
I want to test this.
Oh, you want to test
So
it?
we add
Okay.
those
All right.
pieces of dry ice to
Okay.
this.
All right.
We should
What
be able
should
to tell the
happen?
difference, right? The thymolphthalein should go colorless,
That's
and the
right.
bromothymol blue should go.
Oh,
yellow,
they
yeah?
are different. They
Yeah.
look the same here when we're basic, but if we can change it to acid, the outcome will be different.
Let's go for it.
We got a good
Let's
test.
go for it.
All
Pop
right.
it in there. Let's see if
Okay.
see if Phoebe's right.
There's a shot for that one. Oh, did you
there's the
see
yellow.
that?
There's the yellow.
So
that's-
now we know which
that's the
one.
bromothymol
That's the
blue.
bromothymol
Yep, that's
blue.
right.
And it's so boring. It's not changing to a different color. Now there's no
There it
color.
goes. Colorless.
Okay.
You know, that was kind of nice there for a little bit. We had Spring Arbor colors.
We
We
did.
did. Let's
We
just
Okay.
come on. We
You
got
wanna
Cougar
change
Science
things
Camp
up?
colors. I just want to
Okay.
get back there.
All right,
Hold
of
on.
course, of course.
There might be some Michigan State fans out there that don't like these colors, but some Michigan
Yeah,
fans
well,
might too.
we'll ignore them.
Look at that. Little bit of Spring Arbor colors going
there
on.
There it is. I love it.
If you're a Michigan fan, you're going to call these University of Michigan colors. If you're a Michigan State fan, these are Spring Arbor colors. There you go. That's just the way we'll do it. Yeah? All right.
That's
Well, those
great.
are fun. Let's see what we got next on my list here. I've
Okay,
just got to
okay.
remind myself of what we're doing while we watch those colors go back. Oh, that'd be fun.
Oh,
That'd
what
be
do you
fun.
want to do next?
Why don't you get our candy over there?
The candy.
The candy.
Candy can do the same kinds of things.
Well, we're going to
What
find
are
out.
these?
Sour Patch Kids.
Sour Patch.
You
They
like Sour
taste
Patch
really
Kids, Phoebe?
sweet.
Oh, yeah.
Come on, let's all have Sour Patch Kids.
Okay.
Well, I probably shouldn't because I've been
All
messing
right.
with the I've been messing with the reagents, but Phoebe hasn't a whole lot here.
She has nice, clean fingers.
There you go.
There you go. All
Try
right.
one. Tell me what that tastes like.
Very sour.
Very
Oh.
sour.
Wow.
Anybody else
Very
wanna
sour.
try one
That's
out
why
there?
they're Sour
No?
Patch.
So yeah, so you know, acids taste sour.
They do.
They do. So I'm gonna read the ingredients here to you.
Okay.
Sugar. That's not an
Sugar.
acid.
No,
No,
that's
that's
not
not
an
an
acid.
acid.
That's sweet.
Corn syrup.
That's still quite sweet.
Yep, that's not an acid. Modified cornstarch.
That doesn't have much taste.
Okay, here we go.
Oh,
Tartaric acid. Did I say that right?
you did.
Okay,
You did. Good
tartaric
job.
acid.
Good job. I wonder if it's a
She
base.
just ate an acid. She just ate
Oh,
tartaric
she
acid.
dropped some acid.
And look,
Wow. I couldn't stop it.
and she also ate some citric acid.
Citric acid and tartaric acid
Yeah.
both have what word in them?
I heard acid. I heard
So-
ick acid.
I bet that means they're acidic.
I think you're right.
If you hear the word acid, it means they're acidic.
I think that's right.
Okay.
And you know, we eat acids all the time.
We do?
All the time. Yeah, all
Wow.
the time. It's in a lot of different types of food. In fact, you may have heard of vitamin C.
I have heard of vitamin C.
And I know you know the real name for, well, that we should say the chemical name for vitamin C
Vitamin
is
C is ascorbic acid.
ascorbic acid. So there are acids that your body needs to stay healthy.
Absolutely.
Absolutely. So, you know, it depends, right? Sometimes acids are good for you and you need them. And of course, sometimes they can be damaging as well, like metals and stuff like that.
If I ate all of those at once, it would be too much acid.
I think you might get a stomach ache.
Yeah,
if you
yeah.
ate all those at once.
I
Could
don't
be.
eat too many at once.
Let's do a test with these.
Okay.
Which indicator do you want, Phoebe?
Ooh, we haven't used universal. That's fun.
Let's use universal indicator.
Yay.
So there we go. Let's get a new cup. We're going to test
dropper?
to see if we can't use universal indicator to sort of see that these really are acidic. There's an acid in these Sour Patch Kids. And we're going to use universal indicator. And universal indicator tends to be green around neutral. And then the colors get more yellow, orange, and red in acid. And then they tend to go more blue in a base. There we go. Pop it on there. There we go. Add a little bit of our universal indicator. Now remember, there's some carbon dioxide in here from the air, so this is going to be a little bit acidic. So make a
Maybe
guess as to what
this
color you might see
Part of
when
the
I add the
scale.
universal indicator. That makes sense to me. I usually see that. I see like a, oh, that's a little more acid than I'm used to seing, actually. I usually
Kind
see,
of orange-ish, isn't
I
it?
usually see blue, or excuse me, yellow, but that's, that's fairly common. I'm gonna add just a little bit of base to make this color go just a little bit more basic, just a bit. I think there might
So
still be
right
some
now
left in
it's
there.
here at orange.
Just add a little drop, see what happens. That might go too far. Oh, look at that. Just one little drop. Woo! All the way to
Went
purple.
way up. Wow.
Well, let's test. Let's just throw some Sour Patch Kids in there and see what
Okay.
happens. Huh?
All right. So which way should it go? Should it go even more purple, or should it go green, or maybe even red? I wonder which direction it will go and how
Let's find
far.
out. Why do you think I'm putting a blue one in there?
Well, because it's basic. If it's blue,
Let's see.
everybody knows that.
Look at
Right,
that.
Phoebe? Yeah.
Well, look at that.
Oh,
Look at the
Wow.
power of the Sour Patch Kid.
boy,
Wow.
that's a powerful
That
kick.
went from a really high pH of 14, that means really strongly basic, all the way down to a low pH, that means a pretty strong acid. So that tells me that the acids that we're eating when we eat Sour Patch Kids, they're fairly strong. I think I read an article once where a kid burned his mouth from eating too many of these. You ever read that? I think
haven't
it
heard
did
that
happen.
one, but
Yeah.
Makes
yeah.
sense.
I guess it
It
would.
does, because there's a
You know,
lot
you
of
gotta-
acid.
You gotta be careful. You gotta be careful, but they're fun.
Just a little.
That I wasn't expecting that. That was pretty amazing.
That was much bigger change
See,
than
and
I expected.
I put the blue one in there because I was kind of trying to control for the effect because I didn't want I didn't want to put a red one in because people might have thought that
Yeah,
putting in a
went
red
way-
dye in there is what made the color change
Ah.
when it was really the acid on the Sour Patch Kids
the
that caused the color
powder,
change.
mostly the powder on the outside. That's
Yeah.
the acidic part.
Well, yeah, when I stuck on those, oh, it's so sour.
Well, right at
Wow, is
first.
it? That's really kind of cool. All right, what do I got next for you? Let me just see
Actually,
here.
I have an acid burn, so that's good.
Here, I'll let you.
You got an
I
acid
have
burn?
an acid burn.
Oh,
Oh no!
a
On my
real
knee.
experiment.
Mhm.
Oh, you did?
Oh, what happened?
In laboratory?
Well, no, actually, it's from wart removal. She
Oh.
put too much on there,
Oh, I
and
see.
it actually splashed. So I have a couple more.
Really?
Oh, boy.
Yeah.
Yeah.
Well, acids are useful. They can be used to remove warts on the body, but you got to be careful because it can remove some of your skin too, I guess.
Yes,
Huh?
indeed.
Yeah. Yeah.
All right. We are going to talk about stomach acid. You have an acid in your stomach, and that acid is called hydrochloric acid. And sometimes you get too much acid in your stomach, like if you eat too many of these,
Mhm.
and that gives you an upset stomach. And so what you do is you take an antacid, which is a base. And this
As opposed to
particular,
an uncle acid, which we don't know what that is.
give me the water.
Okay. Thank you,
An
Phoebe.
uncle acid.
An uncle acid. That's not
Let's
even
pour
a
that. Let's
thing.
pour it in there about halfway.
Okay.
So we are gonna play around with this antacid, milk of magnesia. It's what people take if their stomach gets too acidic, and it's just used to neutralize. You know, like you see when we added the acid to the base, it changed the pH. A lot of times you want to try to get to a particular pH, and the one that we want to get to is neutral. The pH is 7. And
So what's the white thing floating around in it, Doctor?
oh, the white thing floating around in there, that's a magnet. And so that magnet there, it's intended to stir the mixture. So there's a spinning magnet in this magnetic stir plate, and you can't see it stirring, but when we place it on there, you sure can see the effect of the stirring magnet inside the stir plate. We can get a little tornado going sometimes. Let's see here.
The vortex
The
of doom.
vortex, there you
Look, it's
go.
coming. Oh,
Let me get my
yeah,
hand out of
that's
the way.
cool.
I heard we had one of those in
Yeah, there
Cold
was
water
one in
last night,
Michigan.
yeah?
Man, look at that.
oh, sometimes it goes
Uh-oh,
too
he went
fast.
crazy.
Yeah, that happens.
That's too much. It's like when you get
Boom.
too excited
There we
about
go.
chemistry, things get out of control.
There we go. Let's
Gotta
try
have
this.
just right.
All right, we'll add a little bit of this. We're gonna add our milk of magnesia.
I wonder what color milk of
You know what?
magnesia
I think it's
is.
better if I do this first. I'm gonna add the universal indicator first. All right. So
Maybe
let's
it's
do
chocolate
this.
milk. We're gonna have to find out.
There we go.
Oh, that's gorgeous.
That is pretty. 2 squirts.
Wow.
Nice orange color. So our
Okay.
pH of our water is somewhere around 4, maybe 5, somewhere in there. So
Okay.
it's a little bit acidic. So we're
Definitely
using the
acidic.
universal indicator.
Yep.
And now I'm going to add 2 squirts of my milk of magnesia, which is a base. And this is, people take this to neutralize acid in their stomach if they get too much acid in their stomach. So let's try this. 2 squirts. There's 1. Oh, look, that pH is
Wow, it's
rising.
really
Oh, look at all those
blinding.
colors. Whoa.
That's a lot of change.
pH 8, I'm getting us at.
Definitely. Kind of a greenish blue.
Let's add a little more. So that the milk of magnesia neutralized the acid that we had. And it's a
Mhm.
little, it's closer to 7, so it's closer to neutral. What you can see is more of
I think
the,
it's leaning
Yeah.
towards blue now.
as more of the milk of magnesia dissolves,
Mm,
it gets more and more
because
basic.
the actual milk of magnesia is basic.
Yep.
So look, it's purple now.
It's
And we saw
very
that with the
basic.
previous indicator with the phenolphthalein.
Look at that purple. Wow, I probably need to change my chart here. We need to put purple here.
Maybe
rather
we
than
do.
blue. Yeah, I need
Yeah.
to do that.
Huh.
Now
That's a
I think
gorgeous purple.
we're going to add some. Let's add some 1 molar hydrochloric acid, which is stomach acid.
There we go.
Hydrochloric acid is the same acid that's in your stomach. I'm trying to squirt it right down the vortex. Is what I'm going to try to
All
do
right.
because it gives me a nice effect. At least it was this morning when I was fiddling around with this. All right, let's give this a shot. I got the nice vortex going.
Yeah.
We're going to shoot this right down the vortex
Right
and
in
see
the
what
center.
happens.
See what happens. It's always fun to see what happens.
Ooh.
Oh, wow. The bottom is acidic and the top is still a little bit. Oh, wait.
I think we're still a little bit basic.
It's
aren't we?
not purple.
What in the world? Look at that. It went red and back to blue.
Yeah.
Wow.
There's a lot going on there.
Now it's going purple, isn't it?
Now it's back to purple. That's fun. Let's do that again. You want to
Yeah.
try it?
Okay.
You can
know,
squirt it at the top. You can squirt it in the vortex.
the
you can do
organic
whatever you
chemist
like.
always
Yep.
does things differently.
All right. Let's see.
It's
Tell
never
us what you're
good.
going to do here. You're going to put it where?
I'm going to put it on the outside.
All right. Oh, look at that. We got it going at the top this time.
Wow.
And he's doing it drop by drop. I did 1 big squirt.
Yeah, because you always overdo things.
A
Looks like the Northern Lights.
little bit.
Does a little bit,
Little
doesn't
bit.
it? Wow.
And
Kind of back where we
back
started.
where we started. This is pretty complicated, but what's going on here is the milk of magnesia, it's a solid. It doesn't dissolve. And so when you squirt the acid in, it pulls it to a really low pH. And then the solid magnesium hydroxide, it reacts slowly with the acid that you squirted in there, and it continues to pull the acid, it neutralizes it, and then if there's a lot of the milk of magnesia, which is a base left, boy, it pulls it all the way back to purple. So you get this really interesting effect with this experiment. And you know what? This is an experiment you'll be able to do at home, not with universal indicator, but there's some food dyes that you can buy where you can do a similar type experiment to see. You can get like 3 colors with like a green and a red and a yellow, I think.
I think those colors.
Phoebe, you want to try?
Sure.
All right.
Come on in here.
You do it however you like.
I'm gonna go in a circle.
Okay,
Circle,
circle.
there you
That's
go.
nice.
Oh, wow.
Oh,
that was cool.
gorgeous.
Look at that. Look at that.
Oh, that was even
well
better.
done.
Wow. That's so cool.
It is.
Yeah.
It's a beautiful experiment. And what we tend to find is when all of the milk of magnesia has been neutralized, you see how it kind of looks cloudy? When all of the milk of magnesia reacts with the acid that we're adding, this tends to go clear because the solid is no longer there. So the cloudiness comes from a solid that's present in the mixture. Let's see if we can, I'm just gonna add a whole bunch to see if we can't get it to go clear. It looks like it's getting a little more clear,
A little bit.
but it's still got some cloudiness to it.
Well, when you say clear, you don't mean colorless. You mean no pieces are left.
That means you
That's
can
what
see through
clear
it.
means. You
You
can
can see
see
through it.
through it easily, like it was just water.
Yeah, it's kind of hard.
Of course,
Can
it's
you
colored.
can you see Kathy through the solution yet?
Not quite. No,
Yeah,
I
your-
can see
your
the
glasses
vortex.
are a little weak today.
You know, there's a lot of reasons we know the magnesium hydroxide is still there. It's because it's still cloudy, and we also know it's there because we're still in the base region if we let it sit long enough. So there's 2 reasons we know why that.
Oh, that's better.
We're
Now
getting
I
there,
can
aren't we?
see the
Let's see.
tornado in the
I
middle.
can
And
too.
before I
Exactly.
couldn't see the tornado.
I can almost. I think we might have reacted it all the way. Let's. Oh no! Look at
Oh, it's coming back.
Whoa.
look at the red tornado in the middle.
Oh,
That's
that's
pretty cool.
gorgeous.
I may have hit it perfectly.
Yeah, I think you might.
If that stays at green,
That's really, really
that's really
even.
fortuitous. That's
Wow,
yeah.
perfect job.
Oh.
I kind of want to quick add some more because I think that may go back to blue. We're really close.
Yeah,
We are really close. Look at that. You got the red
That's so
tornado
cool.
vortex in the middle.
and especially at the bottom, you can see clearly through the solution, although it's evening out now.
Very, very cool. I'm going to add one more big squirt here, and I think we're done with this experiment. Yeah.
Okay, and that cloudiness is gone now.
Hi, Kathy.
Hello.
All right. We're gonna talk a little bit more about carbon dioxide getting into water. And let me show you how this works. Let's take a little bit of some of our water. This is kind of fun. We're going to pour it into this bottle. Some of you may have one of these at home. You may have a home carbonation system. And that's what this here is. It's a home carbonation system. And what a home carbonation system does is it pumps carbon dioxide into water. So if I push on this right here, you hear that? Yeah, let's see if you can see it, the effect on the Sour Patch Kids.
Yeah, yeah.
See that? So when you push on this button here, out of this nozzle comes some carbon dioxide gas. And what we do is we take a bottle like this and we hook it on, and then the carbon dioxide goes into the bottle, And that's how you make soda pop. That's what gives the fizz to soda pop. When you dissolve carbon dioxide into water, that gives the water fizziness. And I love soda pop. I don't know if you do, but I'm a big soda drinker. Love this
Guzzle.
stuff. So let's watch what happens when we take some of our universal indicator. That's this one here. And we're
That
going
one's
to
fun.
we're going to make some soda pop. Well,
Oh,
we wouldn't want to
delicious.
drink this though.
Yeah,
'Cause you don't want to drink the
probably not
universal
this one.
indicator. And it goes.
But you could use the food dyes to do something
Indeed,
similar.
Indeed, you could. Didn't think of that, but that would be a cool thing if
Then
somebody
you could
tries
drink
that.
that.
Yeah.
Might not taste wonderful, but you could drink it.
So let's mix this up. Okay. Boy, that's pretty. It's about pH of 4.
Look at all that fizz. Oh, those are just air bubbles.
Those are air bubbles.
Yeah, they're not as powerful.
Yeah, those are air bubbles. But now what I'm going to do is I'm going to turn this way because you may be able to see just a little bit better with this with no background here. And I'm going to pump some carbon dioxide gas into this bottle that contains universal indicator. What do you think is going to happen? What do you think will happen to the color? Will it stay the same? Will it get yellow, green, blue? Will it go red? Well, let's find out.
I like blue, so I vote blue. Everybody
Spring
voting
Arbor blue, huh?
Yes.
Spring
Spring
Now I'm
Arbor
gonna
blue. That's what I want.
pull this in here.
Because it's about what I want,
All
not
right.
what's actually going to happen.
And let's give this a pump.
What? That's not blue.
That went red, didn't it?
I think it did. Let's see. That puts us at least at pH 3.
Does that make sense?
Well, we didn't just add air this time.
That's right. We didn't add air. What did we add?
What was that gas that we just added, Phoebe?
I believe it was carbon dioxide.
Carbon dioxide.
And we sure know that when you add carbon dioxide to water, it makes that water acidic. Sure
Oh,
enough.
So it makes sense that it went to a red color.
Now, if you do these experiments at home, you can't just open this up like normal. You're really not supposed to add anything to the water prior to carbonating it. And that's because if you turn this really fast when there's something dissolved in it, like universal indicator, it makes a mess. I'll let you guess how I know that. So what you do is if you do this, you got to turn it real slow to get it open. You don't want to do it fast because it can spray all over the place. And I just turn it real slow. And when I first hear the hiss, I just tighten it right back. So here. See how I tightened it right back?
Tightened it right back.
So it wouldn't overflow. There you go. I think we're good.
Hey, Dr. K, we
Yes.
have a question that came in.
Awesome.
What would happen if you put all of the indicators in one solution?
Oh, all four
Well, let's try it.
indicators into one
Can you tell me who asked the question?
That came from the carpenters.
Carpenters. Great question. What pH do you want us to try to hit, carpenters? You know, we're gonna mix all the indicators. Well, let's just do it. Let's just do it and see what happens. We'll put all of them together.
I think he does have
This one.
You got a cup over there for me?
You want to do it in a cup?
And we're gonna try to add 1 drop of all of them.
Okay.
Okay, let me put my my red, well, it's not red soda, my soda with the indicator
Big
over
old red
here.
pop.
Yeah, that's
not red pop. Okay, let's do 1 drop each. So I'm gonna do 1 drop of that. Oh, we gotta do a squirt each, I think.
Looks like
Yeah.
we're going to have to do it that
And
way.
gotta do
that's
a
the
square.
universal that you're.
This is the universal I'm adding. Let's go 1 mil.
So it's right here.
1 milliliter
Neutral.
universal
And then it goes acidic.
because of this. So we're probably at pH 4.
Yeah, looks like
Let's
it.
guess. Colorless.
Plus
Plus
orange.
orange.
Still
plus
orange.
colorless.
Still orange.
So it'd be like a little orange yellow would be my guess.
Okay, could work that
Yeah.
way. You
Let's
never
see.
really know until you try it.
That's right.
And
There
what
goes-
was that?
This was the bromothymol blue. So that's the bottom one.
That's the bottom one. That
This
gives
one?
us the yellow cast.
Okay. Phenolphthalein.
Yep.
Squirt of that. That's this one. We haven't studied that one yet.
Oh, not really.
Maybe I'll use that one for the exercise experiment.
Mhm.
All right. And then finally, where's my bottle of, here it is.
Yep, it's on that side.
A couple drops of this. Then we'll. All right, let's give that a swirl.
Yep. Always got to stir.
Stir it
Oh, I
up.
see some layers in there.
I know, I do too. Don't
Oh,
you?
isn't that pretty?
Wow.
There we go. We're gonna ruin it. See what we get. So I guessed a yellowish orange.
Yeah, that was your guess.
It looks kind of peach to me.
Yeah, yeah. So it could be a mixture of orange and kind of a yellow. These wouldn't add any additional color.
Let's see if we can get it to green.
I'm gonna say, what if we neutralize it?
If we
Yeah.
neutralize it, it'll get
Ooh.
to green, right? Because colorless and green and colorless and green.
Uh-huh.
And then maybe we can get like a purple if we get it here. Because if we add all those
Yeah,
colors together.
the
Well, I don't know. Let's
green.
find out.
I don't know.
Let's see.
Sometimes things work the way you expect them to,
Let me
and
get a new-
sometimes
We'll have to go one drop at a time. You know what? That's too strong, I'll bet you.
one molar.
Don't you think?
Do we have something?
We got tenth molar over there.
Oh, I
What's
put
the
sodium
strength of
hydroxide.
this?
Yep.
This is 0.1 molar.
So,
that's
what we just
1/10.
did there is this solution has a base that's 10 times stronger than this. And since we want to add base just real carefully to try to really fine tune the pH, we're just adding base that's 10 times less strong to see if we can't see the interesting effect. Oh boy, I saw something immediately.
Hmm.
Look at that. Probably from the phenolphthalein. Yeah, let's swirl that.
Ooh.
Oh, that did some changes. Interesting.
We're at orange, a little more yellow. Yeah, that makes
Yeah.
sense.
Yeah, yeah.
Yeah.
So we're
We're
creeping
doing a
up
good
on
job.
it.
Let's do another one. Look at that violet, that like fuchsia color. That's got to be from the phenolphthalein.
It's like a rose.
Yep.
Oh, we definitely are pushing more towards
The blue-green.
blues. And there's only a red. Oh,
We may
no,
have hit
we're
the
closer
green.
to the middle.
Because the
Yeah.
carbon dioxide in the air is helping us, right? Pulling us back from the
It's
blue.
pulling us back.
Let's see if we can't get to that purple color. I don't know.
Oh,
Oh, little blue.
It
So a
was
little
purple at
indigo there.
first. Yeah. So we're probably
There we go.
There it is. There it is.
There we
Then we
go.
pushed it really hard,
Yep.
and now it's a mixture of
It's
all of
pretty with the
these
phenolphthalein
blues
in there.
with the kind of red color.
Phoebe, why don't you grab the glove and drop a couple pieces of carbon
Oh,
dioxide in there,
yeah,
of dry
yeah.
ice in there, just for
Dry ice is the wonder.
There we go. I'll let you throw those out when you're done. Thank you.
Mhm.
Oh, there it goes. Look at that. Look at how quickly that
Way
went.
acidic.
Great question. Thank you. That was kind of fun. And what's interesting is that this is actually how they make universal indicator. Universal indicator isn't just one chemical.
Oh,
They actually put multiple chemicals into universal indicator so that you get the rainbow of colors across the whole pH scale. So that
oh.
we have quite a few.
I thought it was
indicators
just
in here.
one chemical that had that property to change colors.
Yeah,
Huh,
it's
that's
quite a few
interesting.
different ones.
That's
Yeah.
interesting.
So what I'm adding here is some base to this bottle. What do we got? That's about 25 mils. That's pretty good. So we'll pop this in there. Yep. So I've added base to this flask. All right. And I'm going to add to this a little bit of water. Well, I guess we'll make sure and measure the same because I'm going to do another experiment with this. Y'all going to help me do an experiment here. It's at about 100 mils of the water. There we go. Pour that in. And now I'm going to add some phenolphthalein indicator. That's the third one down. Now remember, I added base first. So you should be able to predict what color this will change. I'm using this indicator, base is in here.
base is blue. Because bees go with.
Oh, look at that.
Wrong again.
Look at that. A beautiful pink color. Beautiful pink color. Leave that there. Okay. Now what I'm going to do is I'm going to breathe through a straw into this. And what I'd like for you to do, if you have a stopwatch on your phone, I want you to time how long it takes for this to go from pink to colorless.
Okay.
Now, why would it go from pink to colorless? Well, remember, as I exhale, I breathe out some carbon dioxide. About 4% of the air that I breathe out is carbon dioxide. And that's going to go into this mixture that is certainly basic, and it's going to make it acidic, so it should go to colorless. It's going to take a little while. I'm going to get out my phone while you may be getting out your stopwatch, and I'm going to turn on my stopwatch. And while I do this, Dr. Baldwin, I'm going to ask you, if you would, to put 100 mils of water and 25 mils of sodium hydroxide into another flask, so we prepare another one just like this.
Let's not put it in here.
Okay. All right, here we go. Get my stopwatch. Oh, that's my calculator. There we go. Stopwatch. Let's see how long it takes. On your mark. You got your stopwatch ready? Get set. Got your stopwatch ready? There we go. Go.
Boy, is he blowing hard now.
Oh, it changed colors.
Okay.
I got 17 seconds.
World record.
I got 17 seconds. Now we're going to do that experiment again. So let's see. How did I make that up? I took 20.
That's what Xander got too, was 17.
17
Awesome.
seconds. Good.
Thank you, Xander. Now we're going to get 25 mils of our base. Yep. Here we go. Oh, look at that. There's a little bit of residual phenolphthalein in there. Yep. And then we're going to, my water.
Okay.
Thank you. I'm going to add 100 mils of water. And this time, when we do the experiment, I'm going to do it after I exercise. Usually when I do this experiment with exercise, I run around the room. But the camera's not going to be able to follow me run around the room. So
No,
how
that
in
would
the
be
world
awkward.
can I exercise kind of standing in place for the camera?
Like this. That's my idea.
Well,
Lifting really heavy imaginary weights. That's what he's going to do.
that might work.
That's the Dr. Baldwin method.
Hey, you know what? I could run in place, but I like to bicycle. So I'm actually going to
Oh.
bicycle, and I'm going to do it in
Wow.
place. Here, I'll show you how. I've got these things that I call rollers. Thanks, Dr. Baldwin.
All right, great.
Okay. So usually, okay, I'm going to hold it up like this so you can see it. Usually this is flat. You can see there's some rollers there on the back. That's where my back tire goes. And on the front over here, that's where my front tire goes. And when this is flat on the ground, I can stick my bike on here and I can bike. There we go. I got this set up. I'm going to take my mountain bike. I'm going to exercise for a little bit and we'll repeat the experiment. And the idea is, as I'm exercising, I should be making a lot more carbon dioxide, right? Because I'll be burning more fuel and I'll have to be exhaling more. And I'm exhaling more because I want to be getting rid of the carbon dioxide. The idea is maybe it'll take me less than 17 seconds to neutralize the base while I'm exercising. I don't know if I'm going to try this while I'm exercising. I might exercise, stop, and then try it. I don't think I'm going to try biking and doing this at the same time.
That sounds like a better plan.
Yep. So here we go. Here we go. Get the bike on the rollers.
Wow, you got some.
Oh, I'm getting too old for this. I'm gonna put this up here. I gotta put this here because I don't want that rolling around. All right, here we go. Get on your bike, Dr. K. See how we do this. How long should I go? Oh, I gotta go really fast. Get my, hold on, I'm changing gears here. You get my heart rate up. Burn a lot of fuel. Not cooperating. There we go. Oh. Ah. Woo. Not sweating yet. Wait, maybe I am. Can you see my goggles? They're fogging up.
Oh man, look at that.
I'm going. There we go. I can feel my breathing harder. I'm starting to breathe hard. Woo! Get your stopwatch ready. Get ready. Is my phone ready here? I'll do it here in a second. Oh. I gotta get. The hard part about this experiment is you gotta get breathing hard. Woo! Okay. Get the stopwatch ready. Here we go. Oh. Oh. Oh.
Okay, there he goes. Wow, that was a record.
Whoo.
How many seconds does your watch say, Dr. K?
Mine says, why don't you read it for me?
Looks like 7.79 seconds.
7 points. So that's like twice as fast.
At least.
Twice as fast.
And you are definitely twice as tired
Oh,
right at this moment.
I think I'm sweating, but you gonna help me get my leg over this? Or my quads are burning.
Well,
I'm just kidding. I'm just
It
kidding.
was really
I'm just
awkward
kidding.
before, and I just don't know what's going to happen
No, it's
now.
okay. Here we go.
All right,
Oh,
there you go.
I'm getting too old for this.
Okay.
All right. I can't squeeze through. There we go.
All
Thank you,
right.
sir.
Uh-huh. Got that out of your way.
Xander got 8 seconds. So
Xander got 8, so we were pretty good. All right. All right, let's hope this works. Here we go.
Solution number 1.
I'm gonna let them all change this.
Yep. And keep going until you've seen this before, yeah?
Mhm.
Okay, good,
A couple times.
good.
And you took notes, didn't you, Phoebe?
Oh yes.
Good
That
job.
one, there it goes.
Just
That
makes
one
me
took a
feel
little while.
warm inside to hear students talk about taking notes.
It takes a little while to develop. Oh, look at that one.
Wow, that was immediate.
Yeah.
Wow.
Beautiful.
Mm.
Want me to go?
You go for it.
All right. Solution number 2, going in.
I'm gonna have to add a little more to that first
Yeah.
one. Yep.
Oh, the first one?
Yep. You see it?
Oh, I
Yep,
see.
there we go.
There you go.
Ah.
Beautiful.
Hmm.
Beautiful.
Solution number 2 is doing something.
I think we'll do it in reverse this time, yeah?
Okay, going reverse. Solution number 1, going
Add a
in.
little more, just for fun.
It's much more beautiful now.
All right, Dr. Baldwin, you've
Yeah.
got the finale. We'll be out of your way here.
Okay, so 1 piece in each.
Oh, yeah, probably. Let's see. If we got to add more, we'll add more.
All right. Whoops, got a little crazy there. Maybe that last one needs another. There.
Well done.
A little more power. There.
What's interesting about this demonstration is if you look carefully, you can tell which this was done using acid-base indicators. And when I was adding to the mixtures, each acid-base indicator turns colored in a base. So I was adding base. Phoebe added acid.
Number one.
All of
She
these,
added number two.
all of these indicators are colorless, no color in an acid. So when Phoebe would add the acid, it would go back to colorless.
Mhm.
And of course, carbon dioxide, which is bubbling through the solutions now, is an acid. And of course, they're going to be mostly colorless in an acid. But you can see there's a little yellow color to these here. And what that tells me is that there are two different indicators used to give the red, orange, yellow, and green colors. There are actually two different colors they need to get those, two different indicators. And one of them, the carbon dioxide, is not strong enough to make the yellow color go to colorless. So that's why you see that slight yellow color in these, and that you don't need a yellow to make a blue or a purple.